is our last day, so we have a fair number of things to cover. Let's talk about all the things that we did yesterday, because it basically condenses into this. This is a generalized trig function. It's like 5 times, or in this case, -3 times, a sine or a cosine. You can have a number here like 2, 3, or 4, and then you have an x plus or minus something. So if you have any equation written in this form, there's a bunch of homework questions. I think there's 3 anyway, maybe 4, where you're given this, and your job is to write down what the amplitude, what the period, and what the horizontal shift, which I really don't like that name, so I'm going to put my name in as well, and the phase shift. And amplitude comes from here. You take this number, in this case I've called it b, 2 pi over b, gets you the period. And remember that funny minus c meant you went right and plus c meant you went left. So if it says x minus pi, then your phase shift is pi. So in this case here is the equation. -3 gives you an amplitude of +3, because it's always positive. Since this is a 2, the period is 2 pi divided by 2, which is pi. And then you get a horizontal shift, pi over 6. And then they very often finish with graph it. But isn't that really what Desmos does? So you put it into Desmos, because what they typically do is they give you 4 pictures, and one of them looks like it, and you pick the one that looks like it. Are we cool with that's basically everything in one package, right? So let me just do some examples of what that might look like. There's my first one. Right. So the amplitude would be 4. And the period would be 2 pi divided by 3. Someone here might contradict me here. I think almost exclusively, isn't everything in radians in this section?
I think so.
Yeah. If they have a degree one, okay, you live with it. But I'm pretty sure I didn't see anyone, at least when I scanned through. Right now, the guy they're going to call horizontal shift, which I'll call HS for short. What number is it? Pi upon 6 or negative pi upon 6?
Be positive pi upon 6.
And if you were thinking about visually, aren't you taking a cosine function and just shifting it to the right, pi upon 6? And you plug that guy into Desmos, and you'd be able to see what it looks like. So
that was the only thing that confused me. So like if it's got like, if it was x plus pi over 6,
it'd be negative
the
pi upon 6.
Okay, yeah, that
Right?
makes sense now. Okay.
So that's it. Once you figure out that this minus means a positive horizontal shift, and when this is positive, it means a negative horizontal shift. That's it. And once you figure that out, you're good. I'm trying to nip over. I hope I've got it set up here. And I do. Okay, let's just kill that off for the time being. It's y equals 4 times the cosine of 3, another bracket, x take away, pi gets you pi. So if you type in the little letter p and I, you get pi, and it's what, pi divided by 6. And then I guess we have to close, oops, I don't need the bracket there. I could probably go to the end and it'll figure it out. There we go. Not a very inspiring curve, would you agree? But that's what the curve looks like. You might want to, now that I figured out, because Jason told me how to do it, if you go here, can't you make that 0 and maybe make this, I don't know, you can make it 2 pi or 3 pi or something, and just maybe for no reason except I want to. Good. Oh. Right. And there's the guy. If you only, here's a little trick. If you only want to see, say, one cycle of the thing, right? And what's the period here? 2/3 pi. If you go to the end here, do a curly bracket, do 0 less than or equal to x, less than or equal to, the period was 2/3 pi, so there's 2 pi divided by 3. And then if you finish with a curly bracket, do you see it will only draw you one cycle worth? And then you can, stretch it or do what you like. Yeah, that's probably an easier way to look at it, because then there's only one picture. And in the homework, you'd get 4 to pick, but one of them would look like that. Are we comfortable with that idea? We good? I just want to do 2 more, because the more you do, the cleaner it'll be. And then call that particular topic over with, right? So if I give you a function and it looks like the first one, right? It's got all the features, it looks like this. Can you find amplitude, period, and horizontal shift? And could you sketch it using Desmos? So since I'm only going to do 2 more, I have to go ugly, right? You can't have nice ones, right? You've got to have messy ones. So -3/4, it's going to be a sign. It's going to be pi, right? X take away 3. And I've deliberately picked some ugly numbers. Amplitude, period, and horizontal shift. Okay, amplitude, be careful.
3/4.
Isn't it? Always positive, correct. Phase shift, period, I should say. Period is 2 pi divided by what?
Pi?
Which simplifies down to 2. Just to show you, can't you get periods that don't have multiples of pi in them, right? You don't always get 2/3 pi, you can get that. Now, horizontal shift, phase shift.
3?
3. Now, couldn't I plug that into the calculator and Desmos, I should say? I could do it in my calculator as well, to be honest. And be able to sketch it. What do you think that's going to do to the sine function, that negative? See, a normal sine function goes like that, right? What does a negative do to it?
Then flip it over the x-axis.
Right. Can you hear that as loud as I can hear it? No, I apologize. Yeah. Okay. Last one. Oops. And I've deliberately done something really sneaky with this one. I'm not going to tell you about it yet. Let's get the easy ones out the way first. What is the amplitude?
2.
No problems, agreed. What's the period going to be?
Pi/2?
Oh, you're ahead of the game, yes. Now, let me tell you what it's not. It's not 2 pi. And it's maybe not obvious why it's not 2 pi, but look again. Shouldn't it be a number with an x plus or minus?
1/2 pi.
Right, so what we have to do is figure out what that looks like when you pull out a common factor of 4. So what does 4x minus 2 pi look like if you pull out a common factor of 4? Well, how many x's do you get left over?
1.
1.
Right? And not usual to pull out common factors that don't match something, but nonetheless, I have to. What do you think goes here so that when you multiply it by 4, you get that guy? Agreed.
1/2 pi.
So do you see how that last one, the horizontal shift was kind of hidden? It was kind of hiding there. It's sneaky. So if you were really wanting to do this question, you might want to have done this right at the start before you even answered any of the questions, to rewrite it like that. And then these questions are pretty obvious what the answers are. Kind of sneaky. We doing good? Right. Well, that's that part over with. So what's the next part? The next one is solving equations. I guess I should put in the word trig. Solving trig equations using calculator or Desmos. I like solving these using Desmos. We'll show you how to do it both ways. So we're going to be given an equation with some trig in it, right? And the kind of question that you might get is, if I can find one now, they're always hiding when you don't want them to be. I had it a minute ago, lost it. Scanning. Bear with me for a few moments. I know there's one of these guys around. Probably overshot it. There we go. So first kind we're going to do is solving when is it equal to 0. So let's do 2x, right? So we've got 2x, take away 3 times the sine of x. And we want to solve when is it 0. And x is only allowed to be between 0 and 2 pi. Okay. So on the calculator first, then we'll show you Desmos. Now, this is in radians, so I'm going to hit mode. I'm going to go down to radians, which it is. Make sure it's in radians. You go y equals, and you type in 2x subtract 3 times the sine of x. So far, so good? Right. What I'm going to do now is I hit the zoom button and I choose option 0. Though you can't see it, zoom button 0 gives you zoom to fit. Right. Now, the guy that we're looking for, I'm going to draw roughly what it looks like. It looks like that right now, you agree? When a function this is equal to 0, aren't we interested in those answers there? Right. Now, that one there I don't need to look for. Would you agree x equals 0 works? And you could probably check that out. Now, this one here is going to be a decimal, and we're going to solve it to what they're looking for in these questions. Let's say it's 2 decimal places. I'm sure they jump around. Well, I'm going to take that guy there, and I'm going to hit the button, second calc. Now, there's an option here called number 5. Do you see it intersect? So press enter. And what it asks you is first curve. Oh, darn it, I picked the wrong one. The one we should have been choosing is number 20. That's better. And what it does is it says left bound. And I'm moving my little cursors, although it's underneath the numbers, it's to the left. And then it says right bound. I move my little cursor so it's way to the right, and then I enter. And the answer you get is 1.4957, which rounds off to 1.50. And we have solved it. Now I'd like to solve this equation using Desmos, which is my preferred method. So I'm going to set this guy up. Once I find Desmos, gotcha. And it's pretty much the same thing that I did. It's just a lot easier to do, in my opinion. So I'm just going to type in y equals 2x, take away 3 times sine x. And I could do those little curly brackets and all that good stuff. But can't you already see the answer? I'm clicking on it. Do you see it? 1.50. I mean, isn't that just cleaner? You don't need to do zoom to fit. So unless you're kind of not got access to your computer, I think Desmos is your friend. Okay. Now, there are a number of other questions that you can be asked. Let me restrict this guy to 0 to 2 pi. So I'm going to go 0 less than or equal to x less than or equal to 2 pi. There. What's happened? Nothing should have happened. Where are you going?
Your curly brace.
Oh, shoot. Do you notice I didn't swear there? I'm really good at not swearing. I said SHOOT. I have witnesses, right? Okay, let's try this again. Well, that's a nice function. I'm now going to try doing my curly brackets correctly. 0 less than or equal to x less than or equal to, finish my little curly brackets. Boom. And I need to put in 2 pi. God, that was more work than it's worth. Now, if you were being asked to find the maximum or minimum value of a function, the maximum value of this function would be at the highest point. Would you agree that's pretty close to it? Right, so what's that about?
So I have a question. My
Yes.
Desmos isn't graphing it correctly.
It's not?
No.
What's wrong?
Just it does the 2 swirlies and then it just goes straight up.
So this is what
Oh, never
I'm
mind.
doing. Yeah, this is what I'm doing. Have you got the same function?
Yeah, I got it now. I fixed it.
Oh, you fix it. Okay, good. So this is what it looks like, right? So if I said to you, what's the maximum value? Would you agree it's about here? And what's that, about 13.12? If I asked you for the minimum, oh, that's much better. There's the minimum. Now, we're talking about the y value. So the y value is negative 0.55, and the y value up here is about 13.12. I'm doing that as an eye judgment. Do you think I need to move a touch to the left or a touch to the right? No, that looks good. So you want to get the maximum value of the minimum. Oh, that guy. Oh, that guy. So put that one in, put that one back in. So let me go back and show you what that might look like. So instead of solving this equation, another thing they may ask you for is the maximum value, which is 13.12, and that's basically the height here. And then the minimum value, which is this one here, and that was negative 0.55. Are you okay with how you can use Desmos to find max and min and to solve equations? Are we good? Any questions about that before I look at another example? I'm assuming that's a good sign. And now I have to find my questions. Here we go. So and the next one, oh, by the way, this was essentially question 12, or at least similar to it. Let's do solve cosine x take away x, and the answer has to be in the interval 0 to pi. So let me just make sure that I'm on the page. Right. Did you see that while I was talking, or can you now see it now that I've finished talking? Right. Minimum value was at negative 0.55, maximum value 13.12. In this case, you're being asked to solve this equation, but only between 0 and pi. Right. So let's see what Desmos can do in that case. Okay, Desmos has gone away. Let me try that again. There we are. Desmos is back. Right, so I'm going to try and keep that end bit so I don't have to rewrite it again. And the function that I'm going to do here is, oh, we're being asked to solve cos x equals x. And all I'm going to do is change it to y equals cosine x from 0 to pi. And then y equals x. Now, well, I've got 2 pi's, that's weird. There. If I move this guy and zoom in on him, there's the cosine, there's the straight line. Isn't the point where they intersect that guy? Isn't that the solution we're trying to find? Right? So cosine x is the blue curve, equals x, which is the straight line. And the answer, at least in the range that we're interested in, is 0.739, which makes sense. Shouldn't x be 0.739 and the cosine be 739? So that kind of makes sense. And that's the solution to that one. Doing a lot of jumping around today. Going to get dizzy. So the solution was 0.739. So to 2 decimal places, 0.74. I'm getting enough background noises here. I'm getting another background noise that I'm going to have to.
Oh,
Right.
sorry. I'm unmuted for some reason. I don't know
Okay. Oh, there you go. You're good now. Okay, back to looking at some more homework questions. Right, let's see. Okay, they have a number of questions where they basically, get you to graph it with decimals. So I don't think I need to do this, right? So if you've got a question, graph me. I think we've covered that one. Getting background backs and everything today. All right, so let's see what we can do. Covered that, good. So this is one of the questions I'm not doing, but just to give you an example of what it would look like. Question 15 in the homework asks you to sketch that guy. Right. Now, can you imagine plugging that into Desmos and seeing what it looks like? Actually, if you do it, it looks something like this. Let's get this, right? It looks something like that. And that would be the answer. You pick the one that looks like that. Now, if they ask you to sketch 3, the absolute value of sin x, on Desmos, the absolute value, no, darn it, I should probably stay in Desmos for a little while. The absolute value can be done in Desmos. You just have to know where to look. Okay. Let's suppose we get rid of these two guys. And I would like to sketch y equals 3 times, and to get the absolute value, click on that little guy. You see the absolute value? And then you can put in this case, it's just a sin x. That should be enough, I hope. Yeah. Okay. Doesn't it look like a bouncing ball? Doing, doing, doing. I think that's everything we need on Desmos for a minute. And we move on to a new topic, still in that same section, but a new thing. We're back to finding how to find amplitude and period of functions that look like this. There's going to be a number here, there might be a multiple here, and then you're going to have a sine or cosine. That's the general form of them. Now, I'm going to do the period first. The period is 2 pi divided by that guy. So the period here is a third. So the period is going to be the easy bit, right? If that says 2x, it's 2 pi divided by 2, right? What's the hard one? The amplitude is actually the hard one. The amplitude in this case is how far up and how far down does it go? And people think that that has an effect. Right? What do you think the amplitude of this function is?
1.
1.
1. So what about the -4? Nothing. The -4 does not affect the amplitude, right? If this thing here had been something really ugly like that, what would the amplitude be?
One.
Yeah. Would you agree the amplitude doesn't get affected by numbers like this? It doesn't get affected by numbers in here. Isn't the only thing that you need to look at, even if it's ugly looking, isn't it the number, the coefficient as we call it, next to the sine or cosine? That's the only guy that's going to help or to make this a little bit trickier. Right? So that's just a little special case. How about what is the period of this function?
Pi.
And let's see, she did 2 pi divided by this number, nailed it. What's the amplitude of this function?
5.
Phase shift.
1 pi. Wait.
No, you're right. Fine. Don't change your answer when it's right. It's good. So would you agree this does have no effect on any of the answers? Can you have 5 plus this or 4 minus that? Wouldn't matter, right? Everything you need to know, isn't it, kind of stuck here? And of course, you could sketch it in and get it. Oh, they did one. I've already covered this, but this one is so neat and I just saw it. So let's talk about it. If I asked you for the amplitude, it's 1. Okay. If I asked you for the period and then for the horizontal shift, that's trickier because this guy is not written the way it needs to be written to answer the other 2 questions. I guess the first thing is cosmetic, but isn't it a good idea to have the x's first? Now the important one. You have to pull out a common factor of 3. Okay. If you pull out a common factor of 3, what goes here? Noticing what that is. So what has to go where my finger is so that when you multiply it by 3, you get back to the pi you started with. What goes here?
1/3.
Yeah. Now that you've got that, can't you say that the period is 2 pi divided by 3, and is it the horizontal shift pi upon 3? I kind of missed that one, but I guess that happens. I wonder if there's anything else I missed. Ooh, that's ugly.
Is the horizontal shift negative?
In this case, you are right. I missed it. It's negative. We're getting kind of weird things here. Right, I think I've covered everything except, let's do this one thing and then we can get a head start on next week's work, which is fine. It won't be in this week's homework, but it will be at least a start. And this is a version of question 20.
I was just gonna ask about this one because it looks pretty ugly.
Oh God, it is, isn't it? But it's kind of the ultimate ugly, right? Now, what I'm going to do is try and rewrite this in the form that is going to allow us to get amplitude, period, and phase shift. And the problem is, you can see this, there are fractions everywhere, right? So you're going to have to be on your best, thinking cap situation. Are you comfortable that 3/4 is the weird common factor that you're going to pull out? And that always gets you an X, and I'm pretty sure you should be comfortable with that. The problem is, it's not that obvious what fractional power goes here. Right, it wasn't too bad when the number was 2 or 4, right? You could almost do it in your head. So what I really guess I need is, what calculation would I use to figure out what this number is? So you don't need to tell me what the answer is yet, but just the calculation that you'd use to do it. So you've got this guy, you've got this guy, and somehow or other, you're going to have to figure out what goes in here so that 3/4 times this ends up being that. What's the
Is that
calculation?
3/16 or was it 3/10?
It's a 16th.
It was like delayed for me, so it just changed to a 6, but it looked like a 10. I was very confused.
Is it now 16?
Yeah, it says 16 now, but at first
Right.
it looked like 3/10, and then it just like magically appeared a longer line. So
Kind of weird things happening. Okay, what do you divide? I've gave half it away. What do you divide to make this work?
You divide by 3/4.
Right, so you take this guy and you divide it by 3/4. And you could do that in your calculator, but can't you just turn me upside down? You nailed it. After all the cancelling, it becomes a quarter. Now, if you've got your thing written like that, isn't it pretty much good to go now? So amplitude is 2. The period, we still have to do that 2 pi divided by, in this case, 3/4, which I believe ends up being 8/3 pi when you're finished. And the horizontal shift is just positive 1/4. This time I got it right. Okay, we comfortable with all the things that we've done today? Solving equations, max and min, not much of those, but mostly amplitude, period, and horizontal shifts. Oops, there's that one. Leave that for a second. Give me a chance to get a head start on the next topic. I'm not going to put the next topic online because you don't need to know it until you need to know it, I guess. I'm just picking it up right now myself. It's going to be section 5.4. I have it under future assignments. Take me a few seconds just to set it up so I can actually put it on screen. That looks good. With a bit of luck, it should be visible for me. So and its heading is more trig graphs. And in particular, we are going to be looking, we've already done these two guys, right? And so who are the ones that we're going to look for now? We're going to look at cosecant x, secant x, tangent x, and lastly, cotangent x. And here it goes. I'll go into Desmos again. A second to set it up. And I'm just going to stay on Desmos for the rest of today. So I don't need one about that window. Right. Basically, you can understand or you can see what these various functions look like. If I click on this guy and I do y equals, and I just do tan of x. I don't know if you were expecting that weird shape, right? Now I'm going to restrict it. So I'm going to do 0 less than or equal to x less than or equal to 2 pi. Come back. There we go. Do you see this function has a vertical asymptote? Right, move it up back. If I shrink it there. Do you see the vertical asymptote? It's a little bit clearer, right? And in this case, there's one here, right? And there's another one here. If you zoom in, it's roughly about here. Do you know what angle does a tangent have big problems with? When is it undefined? Because that's where the vertical asymptotes are.
At y equals 0? Like, wouldn't it be vertically?
Right, so what I'm asking is what's the x coordinate, the x value of where this vertical asymptote is? Okay.
Like,
If you look,
half?
yes, it's pi upon 2. It's a half pi.
That's what I meant, yeah.
A half pi is where the tangent has a problem. The reason it has a problem is if you do the y coordinate divided by the x coordinate, you end up with 1 divided by 0 at half pi. Do you know there's another place where you're going to have problems? Isn't it going to be at 3 halves pi? Because then it's going to be, you know, -1 divided by 0. So if you look at this tangent function, can you see here, that's where a half pi is, and over here, that's where 1.5 pi is. Now, if you take off the restrictions, let me copy that again. What is true about all trig functions is they repeat themselves forever. So can you see that the trig function essentially does what it does forever? Now, how about a secant function? And I don't want that. There you go. Right, 1 over the cosine. Do you see it looks a bit like half a happy face? Let's put some, let's move it out a little bit so we can see a bit more. There, maybe it's 6 pi. So I'm just repeating the thing lots of time. Can you see the repeated pattern for a secant is happy face, sad face, happy face, sad face. That's what they look like. And there are vertical asymptotes at fixed points at x equals this, at x equals this, and so on. Any suggestions for what value of x causes a vertical asymptote for the secant function? Where do you think the secant function has a problem? Any ideas?
Is that 1 and -1?
Right, there's pi. Would you agree it doesn't have a problem at pi? Why does it have a problem at pi upon 2? That green line is essentially the vertical asymptote. What's going on for a secant function when x is pi upon 2? Okay, what's the cosine equal to at pi upon 2? Let's raise it that way. What's the cosine equal to at pi upon 2?
Zero.
And isn't the secant 1 over that guy? Do you see why 1 over 0 causes problems? And there's another problem here, right? And another problem here, another problem here. So doesn't the cosine have this happy face, sad face thing? And it basically repeats itself forever. And next week, we'll talk about the period of a cosine. That's a secant. I'll try putting both together. That might be too much, but I'll try. Let's put a cosecant. Is there any obvious relationship between the red secant and the purple cosecant that you can see? You see something going on? Would you agree they're basically the same shape, but isn't one phase shifted? One's shifted. Aren't sine and cosine like that, right? The sine and the cosine look the same, but isn't the cosine kind of shoved to the right a little bit? That's about all I want to say about that thing. So when you talk about the, oh, I haven't done cotangent, that's why I am. There's cotangent. I don't need this fella, but let's put the tangent next to it. The red guy is the cotangent and the purple guy is the tangent. Do you see anything going on here? Shape-wise?
Looks like they're just opposites of each other, like mirror images.
Yeah, that's a good way of saying it. They're like flipped over, aren't they, vertically? Yeah. Would you have expected that from a cotangent and a tangent to kind of look the same, but pointing, you know, I'm pointing left and you're pointing right, I guess is one way of phrasing it. All these shapes have a period. In other words, the distance it takes from the start to where it starts again. So I'm going to hide the cotangent. There we go. Here is the tangent. If you're looking at this point, which is at 0, doesn't it get to here and it repeats itself? Would you agree that that shape repeats itself? So this is 0 and this is pi. Can you see that the period of the tan function is pi? Sine and cosine are 2 pi, right? But for that guy, it's only that one. So I can use this guy to go through the period of the next fella. And this is the cotangent. All right. Now, if I pick a point like there, and then I pick a corresponding point like there, from there to there, isn't that how far before the shape repeats itself? And do you notice that that's also pi, right? From a half pi to 3/2. So those do have a period of pi. Here is secant. Right, I can pick anywhere I like, but I'm going to pick there. Would you agree that it gets to there before it repeats itself? Right. So you start there and it's there. Can you see that the period is 2 pi? And if you do cosecant, if I start here, which is a half pi, and then I finish here, which is 5/2 pi, would you agree that that is also 2 pi? So we have 6 trig ratios here, and this is the relationship for the periods. The sine, the cosine, the secant, and the cosecant all have periods of 2 pi. The tangent and the cotangent have a period of pi. Do you think it makes sense to talk about the amplitude of a tangent function or a cosecant function? No. So we never ask you to find those things because they don't have any real meaning. Could you have a period? Right? Watch what happens. Oh, I'll keep this guy so we've got the original. Now, you could be asked what the period of a given cosecant function is, right? And I'm going to take this guy and I'm going to make it 3/2. Do you notice that there's more black ones there than purple ones, right? Now, if I change this number maybe to a nicer number, like 2, picture's kind of messy, but if you look at this happy face, right, and that happy face, do you notice that there's 1, 2, 3, 4? Have you noticed that 2x, the period shrinks? So the formula for getting periods is 2 pi divided by that number. Isn't it good that it's the same formula? If you want to get the period, isn't it the coefficient of x that you use? So 2 pi divided by the coefficient of x. And that is far too ugly. There we go. What do you think it would be if I wanted to find the period? So what would the formula be for the period of tan 2x?
Same thing.
Would it be 2 pi divided by 2? Or you might want to change it a little bit. Tangent and cotangent have the same kind of relationship. What would it be for a tangent? For a secant, it's 2 pi divided by 2. I agree. But what's it for a tangent?
Be pi divided by 2?
It is. So try and get in your brain that tan and cotangent are special cases, right? See the other 4? The other 4 behave very similar to each other, right? Same kind of rules when they have things that you can calculate, right? But you cannot, you have to change over when you do tans. So the period of tan is pi divided by that number. Let's see if I can do a secant again. You can also have horizontal shifts. Right, there's our nice little secant guy, right? Lots of them. What would be the effect of me subtracting pi upon 2? Isn't that a phase shift of pi upon 2 to the right? So
Does that
pi,
move all the x values right pi upon 2?
correct. Now, that is the new guy. I'll put the original in below so that you can see it. Right. What happened to the black one? That's interesting. Oh, there we go. There. The original function is the red one. Do you see it? The happy sad face. Do you see that this one has a phase shift of pi upon 2? If you look at this guy here and you look at this guy here, do you see that they've been shifted by pi upon 2? Isn't that exactly what you'd expect? So there is no such thing as amplitude for the other 4, but they do have phase shift, and it's exactly what you'd expect it to be. It's the same when the sines and cosines, and they do have a period, and you calculate the secants and cosecants with a 2 pi in it, but you only calculate the tangent with a single pi in it. I think actually that is a really good place to stop. So I'm going to hang about.
So
Yes.
Here's a question that people might be confused on for the homework.
Yes.
It's question 13. It's asking
Oh.
for the frequency.
Oh, I've got a frequency to do. That is cool. Let me find that question. Glad I must have skipped it when I went over, which is not unusual for me. What question is it again?
13.
14. Okay.
13. 1, 3.
Oh, okay. They have a little frequency guy, is that it? Oh, find the period, and you've done that, and then find the frequency. Is that the one you're talking about? Okay.
Yeah.
Right. You're going to like it. It's actually a very easy answer.
Okay,
And I'll just, yeah. The frequency, F, is equal to, okay. I don't know what the question is, but let's suppose the period was 5, right? Just for argument's sake. The frequency then is 1 over the period. So in this case, it would be a fifth, right? If the period was some ugly fraction like 1/400th, the frequency is 1 divided by the period, and that ends up being 400. Are we cool with that? Oh, frequency you use. Do you know when you talk about wavelengths, aren't you talking about frequency? You know, if they say something's got a frequency of 5 hertz, it means it's 5,000 per second. So this one is only 400. So as far as I know about sound, when something's like a whale, isn't the frequency quite slow? Like the frequency might be a couple of hundred. And if it's dead high pitched to give you a headache, won't the frequency be in the thousands? So frequency is just how many times a shape cycles in a second. So glad you caught that. Easy formula, right? Take the period and 1 over the period is the frequency. Did you ever do that in physics? That sounds like something you should have done in a physics class.
I haven't taken physics, so
Yeah. Well, I'm glad you found it. Has anybody seen that relationship? That 1 over the period of something is its frequency? No, no. I guess they don't teach it in physics. Hey, guess what? We now know something that people in physics don't know. Meaning your students, not your professors. I'm sure they know. Right. Did anybody see anything else in that homework that I may have skipped that you don't know? And I think we are finished then. Make sure you've said your last name before you go. Have a nice weekend. Your online test 4 now will be due Friday. It'll be visible probably about 1 o'clock.